Hey everyone, my name is Michaela Brown. I'm going to be talking to you about using Think, Pair, Share as an active learning technique to help introduce kinetics in the chemistry classroom. So a little bit of what I will be talking about. I'm going to introduce what Think, Pair, Share is. Then I will discuss what the topic is that I'm going to be teaching. And then I'll show you how to implement this in your own classroom. First, what is Think, Pair, Share? So this can be used in any classroom, really at any level. It's just a great way to get students talking to each other, to get them thinking at a higher level, and just learning to communicate their thoughts with each other and how to put their thoughts into words. What is Think, Pair, Share? This is a simple and it's an active learning technique. It enables students to utilize higher level thinking, like I mentioned. It also forces students to collaborate and to share with each other. So students that typically might keep to themselves, it gets them out of their shell and gets them talking and thinking out loud. It provides an opportunity for all students to share. This is also a great formative assessment tool, especially right now during virtual learning. This is a great alternative to some standard tests. This is a great way to assess at the end of a unit. How does Think, Pair, Share work? So number one, you have to decide on your target for the lesson. So basically, what do you want to teach? What do you want the students to learn from this activity? In this case, today, it will be to introduce the topics of kinetics and chemistry. Number two, you need to develop a question or multiple questions or just prompts for this specific learning target. Number three, describe the objective to the students and give them short, simple instructions that they will understand and everything they need to know to perform this the correct way. And we'll go over that in more detail in just a minute. Number four, model the procedure to the students. So this is a great time to grab another student, show them what you want them to do, model the behavior in the front of the room or on your computer if you're virtual, and show the students exactly what procedure you want them to follow. Number five, monitor and evaluate students as they perform that specific activity. So here's our steps to the Think, Pair, Share activity. The first step is think. This is where a higher level question will be asked about that specific topic. Students will spend about 2 minutes thinking about what they know about the question or the topic. I would have them write this down or put it in a Google form, something that you can just document what they're thinking. After that 2 minutes is over, then you have students pair up with a partner. You can choose their partner or you can have them choose randomly, whatever you want to do. At this point, students will share their thoughts on the topic, or if it's a question, they'll share their answer to the question. I also require students to ask each other questions to keep that conversation going. So sometimes during the think stage, you can have them write down a couple questions, maybe something they don't understand, or just something that they want to ask their partner later. During the share stage, can be a whole class discussion, it can be a casual group discussion, or you can have the students post their answers to the whiteboard, or there's lots of apps and word generator websites, and I'll talk about that more in just a little bit. I want to add, after the Think, Pair, Share activity, it's a really good idea after the share step to have students stay in their partners and then maybe take a minute or two and discuss and see if their answer has changed at all after seeing everyone's answers or if their way of thinking has changed at all. This is a great graphic that I found online. This is really great when you're implementing Think, Pair, Share. So the think section, it can be a small amount of time. So this says 30 seconds to a minute. It can be during class. It can be before class. You can have them write it down. You can have them type it. You can have them draw. whatever you want to do. In the pair section, you can say turn to your neighbor or walk across the room. You can change up the group sizes. You can say you and your partner need to come to a consensus or agree to disagree. You can make them explain their reasoning, and you can use the wording to share your opinion. In the share stage, this can be a whole group. You can have them get with other small groups. You can have them share verbally or write something down. You can use polling software, which is what I like to do. Or you can just have a good class discussion. Okay, my next section is kinetics. This is what I'm trying to teach, or the objective that I'm trying to get across to my students. This could be whatever learning topic you want it to be. It can be as simple or as complex as you want it to be. For this purpose and this activity, I'm keeping it very, very simple. This is basically an introduction to kinetics. I'm not getting into any of the complex thoughts or lessons. This is just an intro. So it would be great to do the think, pair, share activity as I get into the deeper sections of kinetics and the deeper sections of chemistry that require a little bit more thinking. So here's what I want my kids to know. What is kinetics in chemistry? This is how quickly reactions occur. Changing conditions to see how it affects the rate of reaction. So can we make a reaction speed up or slow down? Kinetics is also important in biological processes and industrial processes. So there's a great little graph at the bottom. What are chemical kinetics? It's the study of the time course behavior of a chemical reaction. How fast does the reaction go? So that depends on the consumption of the reactants and the formation of the products over time. Continuing on, other things I would teach my kids or to introduce kinetics, I would say there's many factors that affect the speed of reaction. These include temperature, the concentration of reactants, the size of the particles, if there's any catalyst, or if there's an inhibitor. You can always go into a little more detail and say raising the temperature speeds up the reactions, lower temperature slows down the reactions. So if I have an increased temp, that's going to cause a whole lot more collisions in the particles, and it's going to cause them to collide more frequently. If you increase the number of particles with enough kinetic energy to become products, that's the goal. You want your reactants to become products. So the more times the particles are colliding, the higher chance that that's happening. A higher temp usually can make the products form faster. For concentration, increased concentration of reactants can also increase the frequency of collisions. For particle size, if there's an increase in the surface area, it increases the amount of reactant that's going to be exposed in that reaction, so it can also increase the speed of the reaction. Catalyst, this can increase the rate of reaction without it being completely used up. It lowers the activation energy barrier, and it can allow more reactants to have enough of that kinetic energy so that they can form products. And lastly, an inhibitor basically inhibits the catalyst by allowing it to not be activated. So again, these are the points that I'm trying to get across to my students just as I introduce the topic of kinetics. Continuing on, kinetics involves collision theory and activation energy. So these are some basic terms that I want my students to know. Collision theory is colliding particles when they have enough kinetic energy. Atoms, ions, and molecules can react to form products. Activation energy is the minimum amount of energy needed for colliding particles to react. I also would like them to know chemical equilibrium. This is when the rates of the forward and the reverse reactions are equal. Then I have Le Chatelier's principle, which I always say that wrong. It's okay. This is when equilibrium is disturbed. the system will adjust to restore that equilibrium. So if there's a disturbance for some reason, this principle just says that things will kind of even out and adjust to restore that equilibrium. There's an example of what this reaction looks like below. Okay, so now that we know what we're teaching and how we would want to teach it, let's put the two together and see what this looks like when we're implementing it in a classroom. This is also a really good active learning activity that I like to use in addition to the Think, Pair, Share. I call it a brain dump, and it's exactly what it sounds like. So it's really beneficial to start a unit by asking the students to do a brain dump. This requires students to write down everything they currently know about a topic. The teacher can then assess what they know already, so prior knowledge, and we can put, as a teacher, we can put more or less emphasis on certain topics. It's also useful to go back to this initial brain dump at the end of a unit, and we can just see how much progress we made, and this is a great tool to gauge student success and how much they learned in a unit. After the brain dump, we teach that introduction lesson on kinetics with those few slides that I just went through. When you completed the lesson on the introduction, that's when I would assign the Think, Pair, Share. So I would do brain dump, introduce kinetics or whatever topic you're doing, and then assign a Think, Pair, Share activity in class. The following slides are to be shown to the students in class. So the next few slides are an example of what I would show my students when I'm trying to do this active learning activity. So this would be on the board. It says, think. Get out a piece of paper and write down question number 1, which I will show in just a minute. You will have 2 minutes to answer the question and write down your thoughts. Also, come up with another question you have about the question or just the topic in general. So here's question number 1. Students need to write this question down, and then I'm setting a timer for 2 minutes. What factors determine the rate of reaction? Okay, let's say my 2 minutes have gone by. This is the next slide I would show. Okay, students, it's time to pair up. Pair up with one person. Discuss your answer to question number 1 and explain your reasoning. You can't just say it is what it is. You need to explain why you think that way. Ask your partner the question that you wrote down. So at this point, I might give them 2 to 3 more minutes to do this section. Excuse me. Okay, here's the last part. I'm showing this to my kids. Answer the question on the Poll Everywhere. So just a side note, Poll Everywhere is a great app that you can use with phones or iPads. It's basically you send out a question to them on their devices, and then they can go and answer it, and their answers will show up on the screen for everyone else to see. Now you can always filter it, so if there's anything not so good or something inappropriate, you can filter that and let it not show on the screen. Okay, so students, answer the question on the Poll Everywhere. Review everyone's answers on the board, so read through the answers as they're showing up. Once we've seen everyone's answers, we might discuss some of them or point some good ones out, point some bad ones out, anything like that. And then we're going to spend 3 minutes with your partner examining all the answers. Would you change your answer or your reasoning? So in their partner groups, this is what they're discussing. Another great thing about Poll Everywhere is it's anonymous, so students are not scared to be right or wrong because their name's not going to be up there. So that was my first Think, Pair, Share. I went ahead and did another one because it doesn't take up a whole lot of class time, so you can shove in 2 or 3 at a time. So here's my second one. I'm going to pretend like I am teaching my students. Okay, students, here's your next Think, Pair, Share. So we're in the think stage. Get out a piece of paper or continue writing the paper that you had. Write down question number 2. Again, you will have 2 minutes to answer the question and write down your thoughts. And then don't forget to come up with another question you have about this question or the topic in general. Here's your question. You have 2 minutes to write down your thoughts and your answer. How do we know when a reaction is complete? So let's say our 2 minutes is up. Here's my next slide. Okay, students, pair up with a different person. You cannot have the same partner. Discuss your answer to question number 2. Go ahead and explain your reasoning, your why, and ask your partner the question that you wrote down. Okay, y'all have 3 minutes to discuss. Okay, students, lastly, I sent out a poll everywhere. Go ahead and answer that survey or that question on your iPads. Make sure you're reading the answers on the board as we go. Okay, let's say that all the answers are up there and we had a great group discussion. Now, students, go ahead and spend the next 3 minutes with your partner and examine all these answers. Discuss if you would change your answer to the question or just change your reasoning, and tell your partner why or why not. Okay, so that is how I would do a think, pair, share for my active learning activity in my classroom. This is something that can work with all ages. Honestly, it can work with all topics of science in general or chemistry in general. It's really, really great at the beginning of the unit or at the end if you want to use it as a formative assessment tool. Here are my references. There's a lot of great ones. My second one that says using the think, pair, share technique. That is a great website that tells you exactly what you need to do for this activity. So feel free to check that out. If y'all have any questions, I do have my school email on there, so feel free to shoot me an email. Bye, guys.